Statistical variance is not just an academic exercise. You can apply high and low bounds to actually manage schedule performance. Here's how. Start with the nominal estimate at complete for time in its classic form. Add the high and low bounds of the estimate. Now, look for trends. What's a trend? It's 3 or more consecutive measurements headed in the same direction. What does a trend tell you? For answers, let's look at some real examples. This is a trend we like to see. High and low bounds converge symmetrically on the nominal. The nominal, in turn, has a flat trajectory. It means that the estimates will be fairly close to the actual outcome. No further action is required. By contrast, here's a pattern we don't like to see. High and low bounds suddenly diverge. That means performance is erratic. The estimates are not reliable indicators of final duration. As soon as the trend emerges, take action to recover the project. Here, there's a synchronous downward trend. That means performance is improving over time. The low bound will be slightly lower than the actual outcome. That's often viewed positively, but it has a downside. It might indicate padding in the schedule. Maybe it's time for action. Finally, here there's a coordinated upward trend in the estimates. That means performance is worsening over time. The high bound will likely end up slightly higher than the actual outcome. Again, maybe it's time for action. When performance is stable, trend analysis signals the likely outcome. But when does the signal call for action? Too early and you lose credibility. Too late and you lose recoverability. For an answer, you need 2 things. First, the performance baseline. That's the planned duration. And second, performance thresholds, limits of acceptable performance. One form of threshold is a fixed percentage of the planned duration. It's usually set by governance documents, project or program plans, or contracts. In our practice, we have used plus or minus 10% as the fixed rate. Another form of threshold is a variable percentage. In our practice, it's derived from uncertainty allowance, and that takes a bit of explanation. Uncertainty leads to risk, and the risk needs to be mitigated. Some uncertainty arises from a lack of knowledge. It creates reducible risk. You buy down the risk with scheduled tasks. They fill in knowledge gaps, and contingency covers the buy down. Uncertainty also arises from the randomness that occurs naturally on projects. You can't buy down that kind of risk. It's irreducible. You can only buffer it through reserve. Use uncertainty allowance to set the thresholds. Add or subtract the allowance to or from the planned duration. Once the thresholds are set, assess the variance of estimates from the baseline. If the variance trends towards a threshold, prepare to take action. If the variance breaches a threshold, it's time to act. Let's work through an example. Start with base data. Get the plan value and the earned value. Calculate the earned schedule and the schedule performance index for time. Calculate the classic estimate at complete for time. And then use statistical analysis to set the high and low bounds for the estimate. Next, graph the estimates. The horizontal axis is for periods. The vertical axis is for estimated duration. The scale runs from 0 to the highest likely estimate. The planned duration is 12, and the uncertainty thresholds are set at 15%. After the first 3 months, what do the results tell us? First, the upper and lower bounds start well beyond thresholds. That's expected. Statistical analysis excludes outliers. It focuses on likely values for the measurements. So the scope of data is less than 100%, but at the start it's still very wide. And the bounds usually begin beyond thresholds. At this point, it's too early to draw conclusions. By 30% of the duration, the estimates stabilize. Again, that's expected. Statistically, more measurements mean less dispersion. Once stable, variance can be used for decision making. Here, the upper bound moves beyond the high threshold, but it's not part of a trend. The lower bound trends toward the low threshold, but finishes just below it. And the nominal is in bounds. So far, there's no call to action. In the final reading, an overall upward trend emerges. The high bound will likely end up higher than the actual outcome. But there are still 5 months to go. Is it too early to take action? Thresholds give the answer. The nominal is in a trend, but it doesn't breach the threshold, so no action is required. The high bound has breached the high threshold, but the dip at the end means it's not part of a trend. Its signals are mixed. The lower bound decides the issue. The variance is in a trend, and it breaches the low threshold. When the low bound is calculated, it's based on the highest efficiency likely to occur. The breach means early completion is unlikely, but worse, even at high efficiency, the planned duration is at risk. It's time to act. Let's summarize, apply the bounds. Start with the classic estimate at complete for time. Set the context with high and low bounds. Then analyze trends. High and low bounds that converge symmetrically to a flat nominal will end up close to the actual outcome. Estimates that diverge don't reliably indicate the outcome. The low bound in estimates that fall synchronously will end up slightly below the actual outcome. The high bound in estimates that rise synchronously will end up slightly above the actual outcome. Next, analyze variance. Set the performance baseline, set threshold values, and then monitor the trends. If the variance heads towards a threshold, prepare for action. If the variance breaches a threshold, it's time to act. For more information on this and other earned schedule topics, here are some references.